You're standing outside a Roman palace. 10,000 soldiers surround you. Your army has siege towers, battering rams, and catapults. You have every advantage. And you're still probably going to lose. Roman palace defenders turned architecture itself into a weapon. And the tactics they used were so ruthlessly effective that military engineers wouldn't fully understand them for another 1,000 years. By the end of this, you'll see exactly how stone, water, height, and pure psychological cruelty combined into the most sophisticated killing system the ancient world ever built. But the most brutal part isn't the walls. It isn't the weapons. It's something quieter, slower, and far more dangerous, and we'll get to that at the end. Before a single soldier swung a sword, Roman palace builders had already made the attacker's life nearly impossible. And they did it before laying a single stone. Location was the first weapon. Roman palaces weren't placed for comfort or convenience. They were placed to make you suffer. High ground was mandatory wherever possible. Hills, volcanic ridges, cliff tops, forcing any attacking force to fight gravity, exhaustion, and exposure simultaneously. Soldiers arriving in full armor after a 2-day march, climbing a 40-degree slope under a barrage of projectiles from above, were already half defeated before they reached the walls. Water features created instant multi-sided protection. Peninsulas, river bends, artificial moats, each one eliminating entire attack angles without requiring a single defender to stand there. So the engineering calculation was simple. Every side protected by water is a side you don't need to staff with soldiers. Approach routes were engineered for exposure. Narrow, winding, deliberately forced into single-file configurations. An army of 10,000 men that can only approach 3 abreast isn't an army anymore. It's a very long, very slow target. And here's what most historians overlook about Roman palace placement. The terrain wasn't just a physical barrier. It was a psychological one. Records show that multiple attacking forces, organized, well-funded, numerically superior, abandoned sieges before a single engagement because the approach itself broke their nerve. When you've marched for days and arrive at a palace perched on a cliff above a flooded plain, with forests blocking your siege equipment and a sheer limestone face mocking your ladders, the mathematics of survival start looking very unfavorable. But the attackers who didn't break, the ones who pressed forward, ran straight into the next problem. The walls themselves were engineering that shouldn't have been possible at the time. We're talking about structures measuring up to 21 feet thick. Not tall, thick. The width of a city bus. Modern visitors who stand beside surviving Roman-era fortification walls and are told the thickness often assume they're being lied to. They aren't. The construction method was a deliberate sandwich. 2 parallel stone faces with a core of rubble, broken stone, and mortar packed between them. This wasn't a shortcut, and it was a calculated structural choice. Rubble cores absorb impact energy in ways that solid stone cannot, distributing the force of battering rams across a massive internal volume instead of transmitting it as a crack. The base of the walls typically featured a sloped section called a talus. This served 2 purposes simultaneously. Battering rams striking a sloped surface lose most of their force. The angle deflects the energy upward rather than into the wall, and siege ladders placed against a sloped base lean outward at the top, making them nearly impossible to climb safely under fire. Advanced fortifications used concentric wall systems, an outer wall and a taller inner wall with an open channel between them. If attackers breached the outer wall, which already cost them enormous casualties, they found themselves standing in a narrow corridor with defenders firing down from both sides. Military historians call this an enfilade kill zone. The soldiers who experienced it called it something less clinical. There's a detail that rarely makes it into popular history. Some wall sections incorporated loose gravel and small stones in specific interior layers, placed where engineers anticipated enemy tunneling attempts. When sappers dug beneath these sections, the shifting material made sound. The walls themselves were listening for you. Every defense we've discussed so far was passive. It worked without anyone manning it. The active defenses were where things became genuinely terrifying. If the walls were the body of Roman palace defense, the gatehouse was the mind, and it was designed specifically to kill you for being foolish enough to enter it. A standard gatehouse entry sequence worked like this. You cross the drawbridge, already a calculated choke point, operated by counterweight mechanisms hidden inside the structure, capable of being raised in seconds. Then you pass through the first set of heavy timber doors reinforced with iron banding. Behind those doors, a portcullis, a latticed iron or timber grate that dropped vertically from above, moving faster than any soldier could react. The most sophisticated designs placed two portcullises approximately 20 feet apart. The gap between them is the detail that matters. Did any attacking force that breached the first gate and pushed into that gap found themselves in a sealed corridor with no way forward and no way back. The ceiling of that corridor contained murder holes, openings through which defenders above could pour boiling water, burning pitch, sand heated to several hundred degrees. The heated sand was particularly effective. It flowed like water through gaps in armor into collars and sleeves and boots, causing burns that incapacitated soldiers without killing them immediately, meaning they blocked the corridor for soldiers behind them. The walls of the gatehouse passage contained arrow loops at multiple heights, allowing archers to fire from protected positions while presenting targets smaller than a hand, and the entire gatehouse structure projected outward from the main wall line, meaning defenders could fire down from above and from both flanking towers simultaneously. You weren't entering a doorway. You were entering a three-dimensional killing box designed by someone who had thought very carefully about every angle. Some gatehouses added a final psychological twist, a deliberate sharp turn in the passage that prevented battering rams from building momentum, and that briefly disoriented soldiers who'd lost visual reference in the chaos. By the time you understood the geometry of where you were, the portcullis was already behind you. Height turned everything in the defender's favor, but not in the way most people assume. The walls and towers weren't just tall, yet they were firing platforms engineered with overlapping fields of fire, meaning there was no position in the approach zone that wasn't covered by at least two, and usually 3 or 4 separate archer positions simultaneously. Tower spacing was calculated against weapon range. Towers placed 100 to 150 feet apart ensured that any attacker between two towers was within effective range of both. Round towers, which replaced earlier square designs, eliminated the blind spots at corners where attackers had previously been able to work unseen. Curved walls also deflected projectiles. A stone thrown against a curved surface glances off. The same stone thrown against a flat surface transfers its full force. Interior spiral staircases curved clockwise, and this meant defenders moving downward, retreating to make a stand, had their sword arm free and unobstructed. Attackers moving upward had their sword arm pressed against the central pillar. It's a detail so small it seems almost petty. It wasn't petty. In a stairwell fight, it was decisive. From the elevated platforms, defenders dropped stones weighing 20 to 50 pounds from heights of 30 to 60 feet. The physics are straightforward and catastrophic. A 30-pound stone dropped from 50 feet impacts with force equivalent to being struck by a full galloping horse. No shield construction available in the ancient or medieval world absorbed that reliably. The towers gave defenders something equally important: time. Lookouts could spot approaching forces days before arrival. Signal fires or flags communicated warnings across distances of 20 miles or more. By the time an attacking army arrived exhausted at the base of the walls, the defenders had been rested, positioned, supplied, and psychologically prepared for hours. The attackers had none of those advantages, which brings us to the defense most people never think about, and the one that actually won the most engagements. Here's what the military histories don't emphasize enough. The majority of sieges against well-designed Roman and Roman-influenced palaces didn't end with a breach. They ended with the attackers leaving. Approximately 60% of recorded sieges concluded with the attacking force withdrawing. Not defeated in battle, not destroyed, just gone. Economics destroyed them first. Maintaining a siege army in the field cost enormous sums daily. Soldiers, supply lines, equipment maintenance, camp construction, medical support. Weeks of no progress didn't just drain morale, it drained treasuries. Many lords and commanders who arrived with every intention of taking a palace simply ran out of money and were forced to withdraw with nothing to show for the expense. Weather was a structural advantage for defenders. Attacking armies camped in open terrain through winter-faced cold, disease, and supply failures at rates that castle defenders, warm, sheltered, and supplied, did not. More soldiers died to exposure and dysentery than to any weapon. Defenders inside the palace were simultaneously conducting psychological operations. Historical records describe defenders eating visibly on the battlements, roasting meat, and ensuring the smell carried toward besieging forces surviving on cold rations. Helmets placed on poles extended the apparent number of defenders. Trumpets and drums simulated the arrival of reinforcements. And when the moment was right, defenders didn't just wait. Small strike teams, sometimes as few as a dozen soldiers, would slip out through concealed sally ports under darkness and destroy siege equipment. Catapults that took weeks to build were burned in minutes. Supply caches were raided. The attackers never knew where the next strike would come from, or when. The palace wasn't passive. It was hunting you. The walls, the gatehouse, the towers, the water features, the terrain. None of these were independent systems. They were layered components of a single integrated machine designed to exhaust you physically, drain you financially, defeat you psychologically, and then strike when you were at your weakest. The most dangerous thing about a Roman palace wasn't how strong it was how slowly it wore you down. These defensive systems shaped military architecture for the next 15 centuries,